Hi, algebra students. This lesson is going to be on solutions to inequalities in one variable. This lesson, we are going to look at how we can find and interpret solutions to inequalities in one variable. For our warm-up activity, it's called find a value, any value. And for these two questions here, they're asking you to find some solutions to the inequality y. Well, I'll let you read that one. And one solution to this inequality here. And for both, just be prepared to be able to justify why that value is a solution. Think through that process of how you could explain. Go ahead and pause the video now, see if you can come up with some solutions for these two inequalities, and then come back. All right, I stopped reading this first one because I wanted to make sure you got some practice reading that inequality sign. This is y is less than or equal to 9.2. Some possible solutions you might have come up with are numbers like 8, 3, 0, -4, any number that is less than 9.2. Even a number like 9.19 could be less than 9.2. And it comes to being able to justify why these values are solutions. Well, if our inequality is y is less than or equal to 9.2, any of those numbers I named earlier, so let's say, for example, -4, we can replace y with -4 and say, why, yes, this gives me a true statement. -4 is, in fact, less than or equal to 9.2. We can use that similar idea of replacing our variable with the solution value for number 2 here, which says write one solution to the inequality 7 times 3 minus x is greater than 14. When it comes to identifying possible solutions for this, notice that the question didn't ask us to solve the inequality. You could have gone about it by solving and then from that come up with a solution. In this lesson here, we're going to talk about a variety of methods you could use to identifying the solution to an inequality. But what a lot of students do their first time trying problems like this is just pick different numbers. Pick different numbers and check to see if you made x that number, would it give you a true statement? If you're going about it a little more strategically, I see that left side is telling me 7 times something is going to be greater than 14. Well, I know 7 times 2 is greater than, 7 times 2 equals 14. So I know that something there needs to be greater than 2. 7 times 2 would make it equal. Something less than 2, like 1, wouldn't make it true. So I need to go greater than 2. That means I need 3 minus x to be greater than 2. And going about it that way can be helpful to make it easier. When you're thinking about numbers that x could be, we could have put numbers like something like -3. You could use the number 0, a really large negative number like -100. Those all are possible values for x. And the reason I could justify that is similar to what we did for that first problem. If I replace x with any of these numbers here, it would give me a true statement. So for example, 7 times 3 minus 0 is greater than 14 because 7 times 3 equals 21, and that is in fact greater than 14. So that's me showing that that value I picked 0 gives me a true statement. When we look at all of these solutions for each of these inequalities, there's a way to represent those solutions on a number line. So focusing in on this last one here, I had come up with 0, -3, and -100 would be down here. We could pick some other ones like -10. These are all possible solutions. When we've got a larger class and there's a lot more people coming up with solutions, you would notice that all of those solution points are on this left side of that number line. All of these solution points are numbers that are less than 1. So instead of me naming all the different numbers that x could be, there's a ton of them, and I can't sit here and name all the possible solutions. Using a number line to show all those possible solutions makes it easier, because then you're not trying to list all the different numbers. We could show that x is a number less than 1 by coming in on this number line here and shading all those different points I was marking. Now, when we think about the number 1 itself, could x equal 1? Well, we could figure that out by doing what we've been doing for all these numbers and substituting. We could say 7 times 3 minus 1 is greater than 14. 7 times 2 is greater than 14. 14 is greater than 14. Is that a true statement? It is not going to be a true statement, because 14 is not greater than 14. 14 equals 14. So we're saying that x, our variable, can be numbers less than 1, but it cannot equal 1. So to show that it cannot equal 1, we don't color in the 1. Instead, we just leave it with like an open circle like that, showing all these numbers to the left are colored in, but not 1. We had looked at graphing inequalities back in pre-algebra, but it's definitely been a while. So that is a topic we're going to be revisiting today. Remember, I said throughout this lesson, we're going to be looking at strategies to find the solutions for inequalities. These are the two questions I'm hoping we leave this warm-up being able to answer. The first one is, how do we know that a value we chose is a solution? And the second question is, how can we use a number line to show the solution set for an inequality? Go ahead, pause the video, and try answering those two questions now. For this first one, how we know that the value we chose is a solution, the theme of identifying anything as being a solution is this idea of using substitution. That is true for equations, for systems, and it's still true for our work in these last couple lessons on inequalities. If it's a solution, I should be able to substitute it in, like I did with this 0 here, and get a true statement. For that second one, how can we use a number line to show the solution set for an inequality? We had talked about in our last lesson how inequalities have a range of solutions. It's not a single number. So we can use a number line to show what that range is. By using a number line to show all the solutions for the second inequality, it's real easy to see from that picture that it's going to be the range of values that are less than 1. And it helps me describe the solutions without having to list out all the numbers. We're going to move on to the second one here, which is going to be all about comparing equations and inequalities in this activity called Equality and Inequality. It starts us off with number 1, which asks us to solve this equation and check your solution. And then they give us a really fun looking equation. We had talked about solving equations earlier in this unit as well back in pre-algebra. I'm going to encourage you to go ahead, pause the video, see if you can solve this equation here. I'm going to point out that there's a negative sign right there. It's really tiny. I almost missed it myself, and I want to make sure you don't miss it. Go ahead, pause the video now and see if you can solve this equation. When it comes to solving this equation, we've learned that there's a lot of different strategies and steps you can use to help you get x all by itself. When it comes to solving this equation, there's 2 strategies that jump out to me for ways we could start this off, and they both have to do with getting rid of that divided by 5 or that fraction there. One is putting that right side over 1 and cross multiplying the 2 sides. The other is very similar. It still involves multiplying. If I want to get rid of that denominator, or that divided by 5, I could come in and multiply both sides by 5. And so that's how I'm going to show it here. If you use that cross multiplying method when you were trying it, it's going to end up giving you the same result. When I come in and I multiply both sides by 5, remember I'm doing that to get rid of this division of 5 over here. So those 5s would cancel out. On that left side of our equation, that leaves me with that negative sign that I'm not going to forget about, the 4 times the x plus 3. On my right side there, I said I was going to multiply both sides by 5, so I want to make sure I'm multiplying everything by 5. When I do that, 4x times 5 gives me 20x, and 12 times 5 gives me 60. So I'm left with this equation here, which is nice because now there's no more fractions. The next thing I personally would do is I'm thinking let's distribute that -4 there. You could have also divided both sides by -4. You might have chosen to do that instead. For our next step, I'm thinking I've got x's on both sides, so let me move x to one side. We could do that by adding 4x on both sides or subtracting 20x on both sides. I'm going to subtract 20x, I think. That leaves me with -24x minus 12 equals -60. Next, to help me get x by itself, I'm going to add my 12 on both sides. That leaves me with -24x equals -48. My last step, I'll divide both sides by -24. And I'm running out of room. And when I do that, I get x equals a +2. We have seen in our work with equations, there are so many different ways you could go about doing these steps. You might have done a couple of them in a different order than I did. As long as at the end of the day, you're getting that x equals 2. A lot of different ways to get to that same result there. They also mentioned checking your solution. Remember, you can check your solutions by substituting. If I substitute this into our equation, I would get 4 times 2 plus 3. All of that is over 5. I'll put that division line in a second. And we get 4 times 2 minus 12. Oh, and you know what I almost forgot that I said I wasn't going to forget is that negative sign that's out front. So we get this that we need to simplify. Let's see, on that left side, I know 2 times 3 is 5, and 5 times 4 is 20. So I get 20 over 5 with that negative sign there. On my right side, we get 4 times 2, which is 8, and 8 minus 12, which is -4. So I'm left with -20 divided by 5. Well, that's -4. So we get that true statement. And I see -4 equals -4. So that helps me know I have found, that was an elaborate check mark. I found the correct solution. For the second part of this activity, remember we're comparing equations and inequalities. So I'm going to draw our attention real quick back to that original equation here. For the next part, they're having us consider this inequality. This inequality is identical to that equation we just saw and solved, except for the fact that it's no longer an equation. Instead of an equal sign, we've got an inequality sign. And they're going to have us do a couple things. For this inequality here, they ask us to choose a couple values less than 2 for x and identify, are they solutions to the inequality? I'm going to have you go ahead, pause the video now and try that yourself. There are a lot of different values that are less than 2. Go ahead and try like 1 or 2 and see what you get. All right. So for this one here, the value that's less than 2 that I'm going to try, I'm going to pick 0. 0 just always seems to be a real easy number to try. If we do that, I am not about to forget that negative sign again. We get this for our left side, and then on that right side, it's a less than or equal to 4 times 0 minus 12. 0 plus 3 is 3. 3 times 4 gives me 12. So I'm left with -12 divided by 5 is less than or equal to 4 times 0 is 0. So that's just a -12 there. Negative, and I'm going to move it over here. -12 divided by 5 is -2.4. So we get -2.4 is less than or equal to -12 as that final result. It might help to think of that on a number line because comparing negative numbers sometimes is tricky for students. -2.4 and -12. -2.4 is here. -12 would be down here. -2.4 is the greater value. It is closer to 0. It's further to the right. So this right here would not be a true statement. -2.4 would be greater than -12 there. Any value you chose, you might have picked a different number than 0 to try. We're getting that it's not a solution. Part B says choose a couple values greater than 2 for x. Are they solutions to the inequality? Similar to what we did before, but now you're choosing a number bigger than 2. Go ahead, pause the video now and pick 1 or 2 values to try yourself. All right, for this one here, I think I'm going to pick the number, let's do 7 for mine. I'm going to do that negative 4 times 7 plus 3. All of that is divided by 5. And that side is less than or equal to 4 times my x value, which I chose 7, minus 12. And let me go in with that divided by 5 there. When we do the math there, we've got 7 plus 3 is 10. 10 times negative 4 is negative 40. So on that left side, I'm left with negative 40 divided by 5 is less than or equal to 4 times 7 is 28. 28 minus 12. We do some math. Negative 40 divided by 5 is negative 8. So we get negative 8 is less than or equal to 28 minus 12, which is 16. And that is a true statement. Chances are you probably picked a number different than 7 for numbers greater than 2. Whichever number you chose should have also been a solution to the inequality when you substitute and do the math. So we're getting that values less than 2 are not solutions. We're getting values that are greater than 2 are solutions. What about 2 itself? Is 2 itself a solution to this inequality here? Well, we've already checked the math up here with 2. We found that when we substituted 2 into the equation, we've got negative 4 equal to negative 4. All the math we would do would be the same. The only difference is instead of that equal sign there would be a less than or equal to sign. So what do you think? Would 2 be a solution for this inequality? Our answer for part C is yes, it is a solution for this inequality. It's a solution because when you get that statement, negative 4 is less than or equal to negative 4, negative 4 isn't less than negative 4, but negative 4 is equal to negative 4. So it would make that inequality true. The last part of this question here is graphing the solution to the inequality on a number line. At this point, we figured out from our different test points we used that numbers that are less than 2 are not a solution, numbers that are greater than 2 are a solution, and 2 itself is a solution. That is enough information for us on this graph to show what that solution set to the inequality is. We would start at 2 itself. Remember when we solved the equation, that was 2. That's giving me a boundary to our inequality, or like a starting point. So on my inequality, I'll go to the number 2, and we figured out that 2 itself is in fact a solution. To show that 2 is a solution, I can go ahead and color in that 2 there. Now the other solutions for this inequality we figured out were numbers that are greater than 2. To show that numbers greater than 2 are a solution, we just shade to the right 2 of 2 like that. So to summarize what we're doing here, we had talked about ways you can identify solutions for inequalities. In the first part, if you're just trying to figure out if a number is a solution, you can use this idea of substitution. Up here, I wasn't asking you to solve the inequality. We were just trying to find a solution. And so if you're trying to find a solution or check to see something is a solution, you can use substitution. When it comes to solving the inequality itself, it can help to solve the related equation. Pretend the inequality sign isn't there, solve the equation, and you'll get that starting point of your inequality. And then for the other part of the solution set, just checking numbers below or above. One side is going to be a solution and the other side isn't. So doing what we did here in parts A and B to figure out which side would be shaded and which set of numbers would be a part of the solution set. There's one last strategy you can use when you're trying to identify a solution set, and we'll talk about that in this last activity here. This last one here is called Off to an Orchard, and it says a teacher is choosing between 2 options for a class field trip to an orchard. At Orchard A, admission costs $9 per person and 3 chaperones are required. At Orchard B, the cost is $10 per person, but only 1 chaperone is required. At each orchard, the same price applies to both chaperones and students. That last bullet point there is just saying if it says it's $9 per person, it's $9 for each chaperone, and it's $9 for each student. Same thing with the $10. Number 1 is asking us to figure out what would be the cheaper option. And isn't that always the question? We always want to go with whatever is going to benefit us most. So as a teacher, she's trying to decide what's the cheaper option. We're looking at 3 different scenarios. If she has 8 students, 12 students, and 30 students. Go ahead, pause the video now and see if you can figure out which orchard, A or B, would be cheaper for these different amounts of students. All right, for the first 2, Orchard B would be the cheaper option. And then for that last one there, Orchard A would be the cheaper option. For all 3 of these, the strategy I would use is just figuring out how much each orchard would cost given that many students and then comparing those total costs. For example, for 8 students, Orchard A, if there's 8 students going, it would cost $9 for each of those 8 students, plus the $9 for each of those chaperones. So we can figure out that total cost by saying for Orchard A, there would be a total of 3 plus 8, 11 people going. So we need to multiply 9 by 11, which would give us a total of $99. For Orchard B, if 8 students were going, it would cost $10 for those 8 students, but also $10 for that 1 chaperone. So I could figure out how many total people are going by doing the 8 plus 1 to get the 9, and then multiplying that by the cost. So that costs $10 per person. There are a total of 9 people going, so that would equal $90. And from that math, we're able to see which option is the cheaper option. Moving to the second part here, it says to help her compare the cost of her 2 options, the teacher first writes the equation 9 times n plus 3 equals 10 times n plus 1. And then she writes the inequality 9 times n plus 3 is less than 10 times n plus 1. The first question is asking us what n represents in each statement. I'm going to go ahead and come back up here a little bit. I'll also go ahead and copy those inequalities that she wrote up here. The first, or inequality and equation. The first one was 9 times n plus 3 equals 10 times n plus 1. And that second one was the exact same thing, except with an inequality. That first question is asking us to figure out what n represents. Looking at this information given, see if you can figure out what that variable n represents. I think comparing the equation and inequality to the math we did earlier can be helpful in figuring out what that variable represents. When I look at the left side, I see we're multiplying 9 times n plus 3. 9 is that cost per person. We're multiplying that cost per person by n and by 3. Well, 3 is those 3 chaperones going. Remember what math we had to do earlier to get that 11? We had to add the 8 students to the 3 chaperones to find how many total people were going before we multiplied the cost per person. That n there represents the number of students going. We're saying it's $9 for each of those students and $9 for the 3 chaperones. Similar over here for Orchard B, it's $10 for each of those students and $10 for that 1 chaperone. So n we get represents the number of students going. The second question here says, in this situation, what does the equation mean? We've got this equation right here on top. What is that equation describing in this situation? Well, we saw from earlier that left side of the equation is representing Orchard A. That right there represents Orchard A, specifically the total amount of money you spend there. remember earlier when we did that math, we got that $99. So it represents that total cost of orchard A. Similarly, this right side here is describing the cost of orchard B. So when you put that equal sign there, what does it represent? Well, it represents the cost of those two orchards being equal. So when it comes to this equation, if I were to solve it, would tell me the number of students that would need to go to make the cost of orchard A and orchard B equal. Well, that's not all she wrote. She also wrote this inequality here. Use what we had talked about for that equation to see if you can figure out what does this inequality here describe. The question is, what does the solution to the inequality n times, I keep saying n, 9 times n plus 3 is less than 10 times n plus 1 tell us? And I'll come back up here so you can see all the information. Well, similar to what we did before, in the inequality, that left side is still describing orchard A, the right side is still describing orchard B, but now we've got a less than sign in between them. So what that inequality is describing is orchard A costing less money than orchard B. It asks, what does the solution to the inequality tell us? Well, if I were to solve that inequality, it's going to tell me how many students would need to go to make orchard A cost less than orchard B. I'm going to write that down just so we don't forget. The solution is telling me the number of students that would need to go to make orchard A cost less than orchard B. And make this a little tinier so it fits. There we go. Keeping that in mind, we're going to graph the solution to the inequality on the number line. And like always, be prepared to show or explain your reasoning. When it comes to this inequality here, we've already talked about some strategies you can use earlier in this lesson to help you identify the solution set to this inequality. I'm going to encourage you to pause the video and try doing that now. One strategy we had talked about is guessing numbers, picking numbers to substitute into this inequality, and from that identifying which numbers are solutions and which ones aren't. There are a lot of different numbers, though, if you're going that guess and check route, that you would have to check. We did 3 earlier, and that math takes a while to do. So if we are going this route of picking numbers to figure out the entire solution set, it will definitely get you there, but you might have had that video paused for a while if that's how you were doing it. The second strategy we talked about is solving the related equation. We've got that related equation right here. If you solve that equation, it's going to give you that boundary number, that starting point of the inequality. After that, you could check numbers on either side. So let's say, for example, that we get n equals 10. You could check numbers that are less than 10 and numbers that are greater than 10 to figure out which way it would need to go. If the solution is going to be numbers less than 10 or if the solution is going to be all numbers greater than 10. The last way you can go about this is solving this inequality here itself. I'm going to copy that inequality down here. We've got 9 times n plus 3 is less than 10 times n plus 1. If I'm solving it as an inequality and not solving that related equation, well, even if you solve the equation, it's going to start off the same way. Let's distribute that 9 and distribute that 10 to get this. I've got variables on both sides, so I need to move the variable to one side. You could do that by subtracting 9n or subtracting 10n. I'm going to subtract 10n here. And when I do that, I get negative 1n or negative n. I'm just going to write that 1 there for now. And then to get rid of our constant, I need to subtract 27 on both sides. If I do that, I get negative 1n is less than negative 17. And then our last step here would be to divide by negative 1. Divide by negative 1. When we do that, on that left side we get n, And on that right side, negative 17 divided by negative 1 gives us a positive 17. When it comes to inequalities, way back in pre-algebra, we had learned a rule that said when you're solving an inequality, if you multiply or divide by a negative number, like I did just here, that inequality sign needs to change. It needs to go the opposite way. So instead of being a less than sign, it would be a greater than sign. Now, when it comes to rules, rules are easy to forget. And so I still want to encourage you, if you're going this route of solving this inequality, it's still good to do like a test point and check a number to make sure it is a part of a solution set. It's real easy to forget that inequality sign needs to change and just copy down the less than sign instead of a greater than sign. So once we get that n is greater than 17, I would still encourage you to do what you would have to do if you solved the equation and pick a number bigger than 17 just to make sure it works in the inequality, just to make sure you correctly solved it. So for example, we're saying n needs to be greater than 17 to make orchard A cost less than orchard B. Let's pick a number greater than 17. I'm going to pick 19. If we pick 19, we've got 9 times, let's say 19 plus 3 is less than 10 times 19 plus 1. And if I've done this correctly, if n is in fact greater than 17, I should see that this gives me a true statement. We get to do some math here. It's going to be 9 times 19 plus 3 is 22 is less than 10 times 19 plus 1 is 20. That 9 times 22, goodness, 198. And then 10 times 20 is much easier, is 200. So we get 198 is less than 200, which in fact is true. So that way it just gives you a good idea that you found the correct solution set. If we were to pick a number greater than 17 and substitute and see that it's not true, it tells me something's wrong with my solution here, which when it comes to that rule of flipping your inequality sign, that's a real easy rule to forget. When it comes to that checkpoint, we checked 19 here just to confirm that it was true. Remember earlier we picked these 3 numbers to check, and notice when we did 30 students, Orchard A was cheaper than Orchard B, which is what we're trying to figure out in this problem here, is how many students would need to go to make A cost less than B. So we already saw earlier that those larger numbers, like 30, numbers that are greater than 17, also make Orchard A cheaper. That last part is asking us to graph that solution set. We've figured out now that the number of students that need to go needs to be more than 17. So I would need on my inequality there to be a 17 to start from. I'll put 17 right in the middle. Can n equal 17? No, this is saying it needs to be greater than 17. So I'm going to use an open circle to show that we are not including 17 in our solution set. And then to show that it's greater than 17, we're shading this direction here. So to summarize all these different strategies we have for solving inequalities, one strategy you can use is this idea of checking different numbers and checking to see if a number is a solution point by using substitution. Another strategy, if you're trying to find the entire solution set, is by solving a related equation and then checking numbers lower or higher than that solution to see which way that shading should go. The last solution is solving the inequality itself, making sure to remember any rules, like this rule here, that when you multiply or divide by a negative, you flip that inequality sign. But then always, it's still a good strategy to pick a checkpoint just to make sure you found the correct solution. As a way to check to see where you're at with this lesson, I've got a cool down here, which says which graph correctly shows the solution to that fun-looking inequality there. Show or explain your reasoning. Go ahead, pause the video now and see if you can correctly identify which graph would match up with that inequality. All right, the correct answer for this one is C. If you got C, that's a good sign that you're on track with this lesson. If you picked another one, don't fear. We're still going to be doing more work on inequalities. But if you're finding that this is something you're struggling on, maybe it really is just the solving the equations and inequalities, or maybe it has to do with this idea of identifying the graph, whatever it may be. Just remember that we do have tutoring, and we always, always, always love seeing you all for tutoring, and we are here to help. Thanks so much for watching, and have a great rest of your day. Bye.